For the first of two tech talks. We are listening to Andy talk about Bun tonight, a potential alternative to Node.js and Dino. Can we do a quick round of applause for Andy?
Yeah, let's go.
Let's go.
All right, Andy, take it away.
All right, thank you so much for that introduction, Dewey. So like Dewey said, tonight I'm going to be talking about the Node.js alternative, up and coming alternative known as Bun. But before that, I would like to thank Jeannie and Bracklet for giving me the opportunity to talk on their tech talk series. So without further ado, here we go. So Bun, look at that cute logo. Their motto is a fast all-in-one JavaScript runtime, and that's what we're going to be talking about today. No spoilers yet, but we're going to get to it. So, introduction. We're going to be talking about this in a series of the different parts. First, I'm going to be asking you a couple questions, like what exactly is a JavaScript runtime and what exactly is a JavaScript engine? A lot of people, I feel, get confused between the two, or might think that they might actually be the exact same thing. But just to clarify, we're going to go over that and just get that distinction out of the way. Next, we're going to be talking about a couple popular runtimes that developers often default to that they use for their everyday development, either for self-fulfillment projects or for their companies. And then we're going to be going into what exactly Bun is and potentially why Bun might be relevant to you as a developer, as a non-developer, or just someone who is curious about the topic. Okay, so jumping straight in, we have the engine versus the environment. Like we said earlier, there often is a misconception between the two, engine versus environment. Briefly put, an engine is designed to read, parse, and convert your code into commands that your system can understand and perform some kind of execution. On the contrary, a runtime environment is designed to provide objects and the necessary data for your JavaScript to allow for interaction outside. So in the old days, JavaScript was specifically ran and confined within browsers, and there wasn't really necessarily an environment where JavaScript could exist on the back end. And that JavaScript was mainly used on the front end within browsers, and other backend languages accompanied it, such as Java and PHP. Those were typical languages used for web development back in the day. But in recent times, 2009 to be more specific, Node.js came around and changed all of that. This is where the introduction of runtimes came to be. Node.js was developed utilizing Google's V8 engine with the intention to allow for JavaScript to be executed outside of a browser environment, thus creating a more streamlined developer approach. So that way developers could use a single language, JavaScript, to develop full stack applications for both front end and the back end. So I want to talk briefly a little bit about this metaphor, these two examples on the side. This is taken from Luo Jinghui from Stack Overflow, and I'm sorry if I butchered his name. But if we imagine a robot is playing music, the JavaScript code would be the musical notes to the robot. The JavaScript engine, on the other hand, is the actual robot, which can understand the notes and would have to act upon those notes to play those necessary keys or musical notes. The JavaScript runtime in this situation would actually be the instrument itself, which is allowing the robot, which is the JavaScript engine, to actually play that music. So the robot would be able to interpret those notes, but it won't really have all the necessary tools to be executing and performing those actions. And that's where the runtime comes in. It's allowing the robot to have the necessary tools to read, parse, and interpret those lines of code on our screen to actually perform some kind of execution. On the second example, if that first one wasn't really clear, we have a robot putting out a fire. JavaScript code would be the instructions to put out the fire. And the JavaScript engine would be the robot which can actually understand those instructions and perform actual actions necessary to put out the fire. However, without the necessary tools like a fire truck or a water gun or a bucket of water, whatever the means be, to put out those fires, the engine wouldn't be able to do it. So that's kind of the difference between an engine and the runtime engine is used to read, parse, and convert the code into commands, while the runtime environment is what allows those commands to actually be executed along with the necessary tools. Cool. So just going very briefly, surface level with these popular runtimes. I don't want to go too much in depth for what we were going to be talking about today, but just a very brief background about these popular runtimes. Node.js, conceptualized in 2009, was written in C++, built on the V8 engine, which was designed for Google's Chrome. It features a centralized package manager, NPM. It does not come out of the box with TypeScript support because it came from 2009 and it was specifically designed for JavaScript programs. So, but TypeScript is enabled through packages and other libraries and configs. It features CommonJS and eventually started to support ESM modules later on in future versions. Deno was created in 2018, which was created by the same creator as Node, but is supposed to be an alternative, a better version of Node to solve its shortcomings. Was written in Rust, is built on the same V8 engine. It utilizes URLs to import packages directly into the application rather than using NPM. It is built-in TypeScript support because it is a modern runtime, and it features ES modules, which are the standard for JavaScript today. Finally, we can be talking about Bun. So Bun is the project that I'm really interested in. I want you guys to be aware of because this is a potential upcoming technology that, who knows, maybe you guys might be using in the future. So I've been alluding to Bun this whole time, but what exactly is Bun? So Bun, like mentioned earlier, is this fast all-in-one JavaScript runtime built on 3 key principles: speed, performance, and completeness. And when I mention completeness represents that Bun is a full stack application, not just an environment. It features a built-in bundler, it features a built-in transpiler, and it also features a built-in package manager. So it includes everything necessary for modern applications to be complete. Bun is also very easy to implement to existing projects just because it has such good support for JavaScript and TypeScript applications straight out of the box without needing any specific configurations or extra files or packages or libraries, whatnot. It natively supports 90% of existing Node API functions, such as file systems, path, buffers, and etc. So it should be very seamless plug and play into your existing applications if you choose, to try out Bun. Keep in mind, though, that it is an experimental feature. So there are going to be bugs that will be ironed out in the future. Currently, Bun is only supported on macOS, Linux 64, and Windows subsystem for Linux, or also known as WSF. So the features of Bun, what makes Bun unique and what makes Bun so special? So Bun features a built-in web API support for popular web APIs, such as Fetch, WebSockets, and readable streams. These are all very customized features that were built specifically for Bun that will run a little bit differently than how it runs on other runtime environments. It also supports ESM and CommonJS support. Reason why it supports CommonJS still is because older legacy projects written in Node or utilizing Node still might utilize CommonJS and the require syntax and the module exports syntax and such like that to accommodate for those. So as mentioned earlier, Bun transpiles every single file within the environment. So there is no need to include extra configurations for TypeScript files, as well as additional libraries or packages to support JSX functionalities as well. So React and TypeScript work right out of the box with this environment. Bun also features a ultra-fast SQLite 3 client used to query SQLite database, which is one of the most widely adopted database engines in the world, actually. So it's fairly common to run into SQLite. And we'll go into that a little bit later. Bun also features customized methods utilized for fast system calls to write, copy, pipe, send, and clone files. Some of these methods include bun.write and bun.transpiler. Another cool feature that Bun offers is that it automatically loads environment variables into your application. So gone are the days where we need to actually import.env into any of the files just to access those specific env files and variables, it automatically does it. So all files within your environment has access to those variables. The final feature that Bun implements is its ability to call native code from JavaScript using Bun's FFI, which stands for Foreign Function Interface. There are a bunch of other features, but these are the notable features that I wanted to showcase today. If you're interested, they're on the Bun website, and you can check them out for yourself. So I've been alluding to the fact that Bun is really fast, but here are some benchmarks from the Bun's official website showcasing just how fast it is. And I wasn't kidding when it was fast. So if we look at the first diagram, Bun, utilizing the method bun.serve, Bun is able to deliver server-side rendered React in the form of HTTP requests per second, significantly faster than the counterparts of Node and Deno. Right? If we look at WebSockets as well on the second diagram, WebSocket server chat, in terms of messages sent per second, we can see that Bun also significantly throws Deno and Node out of the water. And finally, Bun.serve, this is referring to the SQL, built-in SQLite client that Bun offers. It is also significantly faster in it being able to query and load a huge table relative to Deno and Better SQLite 3, which is a separate client specifically for SQLite 3. So we can see how fast it is here. So why is Bun so fast, and how is it able to achieve such speeds? And why is Node not able to keep up with these speeds? Well, Node is built on relatively old architecture, and it's written in the language C++, so it is relatively difficult to circumvent old problems utilizing old technologies. So they have, like, progress is slow, and there's a lot of problems that you just can't, like, circumnavigate. While Bun, on the other hand, is built from scratch. So everything was designed from the ground up, utilizing the newest technologies, the newest standards, and everything to achieve the maximum possible speeds. The team spent enormous efforts and time benchmarking, profiling, and optimizing these methods and system designs so that Bun could achieve maximum speeds utilizing current technologies. And we can see that through the benchmarks that I just showcased in the previous slide. Well, another part of the reason why Bun is able to achieve such fast and ridiculous speeds over its other counterparts is that it's built upon JavaScript core. So as I mentioned earlier in the previous slides, JavaScript core is an engine. So an engine is, being able to parse, read, and perform actions on your specific code. It's built on JavaScript core, which is created by Apple, designed for Safari, which is generally is faster than its Google V8 counterpart. And interestingly enough, Bun is also written in Zig. So a lot of you guys might be wondering what Zig is currently. Zig is a low-level programming language designed for memory management. It's supposed to be easy to pick up for developers, so developers could focus more on debugging the actual application rather than debugging and reading documentation for the actual language. Zig also offers developers the ability to fine-tune every single minute detail regarding their application and how memory is allocated within each individual step. So with that all in mind, I want to showcase a couple other reasons why, or how all of this is able to make Bun so fast. So on the right, if we see Bun install, utilizing Zig and all of the JavaScript core engine, we can replace Yarn and NPM for up to 20 times faster package installations with Bun install. These custom methods are literally designed for Bun from the ground up to focus on performance. So Bun WIP test, work in progress test, is their new and testing system that is still a work in progress that supposedly runs faster than Jest, that can run a full system test faster than Jest can even print its version number inside of the console. So that's crazy to think about. But what's even crazier is Bun Run, which is an alternative for NPM Run, supposedly allows you to run package.json scripts 30 times faster than NPM Run, equating to an average savings of 160 milliseconds per run. So just in terms of efficiency, it's astronomical. Okay. So with that out of the way, we're going to go into why Bun might be relevant to you. Well, Bun is still a relatively new technology, and a lot of people still don't know about it, which is why I'm here talking about Bun tonight, trying to spread the awareness a little bit. It's extremely new, but yet it shows exceptional promise, given how fast everything runs. It is a potential competitor of popular runtimes in the future for sure. And innovating and pushing current technologies to the limit by min-maxing and just utilizing technologies to push, unbelievable speeds, like 30 times faster. And, who knows, Bun might be relevant to you because you might be a future Bun contributor. And with that, I want to thank you guys for listening to my tech talk today. If you guys have any questions, you guys can reach out to me. Questions or concerns, you guys can reach out to me on my email, my LinkedIn, and my GitHub. If you guys just want to connect as well, you guys can also reach me out there. Thank you.
And go ahead and unmute. Give it up one more time for Andy on his great Bun talk.
Yeah.